Hello everyone. Today we are going to discuss a gate question. Just imagine that we have got a cantilever bar. I should call this as a bar or a rod, not a beam, because this will be subjected to axial load. Now let me define the geometric properties of this bar. This bar has got a length of magnitude L. Its cross-sectional area is A. Now, what about the material property? This bar is made up of material such that if you plot the Young's modulus along the y-axis and the length along the x-axis, the Young's modulus actually varies in a linear fashion. Let us say that at the fixed end, the value of Young's modulus is 1 into 10 raised to the power 5 Newton per mm square, and the Young's modulus value gradually increases as you progress towards the free end of the bar. You may ask me this question, how can such a bar be manufactured? But let us assume that such a bar exists and try to answer the question. Now this bar is subjected to a point load of magnitude capital P. The question here is, how does the stress actually vary with respect to the length? It's a very simple question, but a question to actually trick you. We know that the stress is given by load divided by area. So the load is actually a constant because the load is not actually going to vary with respect to the length of the bar. So the load is constant. Also, the cross-sectional area never changes. So according to this formula, the stress is actually constant throughout the length of the bar. So that is the answer. Now you may argue that the stress is also given by this equation, Young's modulus into strain. Because the Young's modulus increases, what should actually happen is the strain should actually decrease in such a fashion that any increase in Young's modulus would be nullified by the corresponding decrease in strain to keep the value of the stress constant throughout the length of the bar. So the answer to the question, the stress remains constant throughout the length of the bar. Hope this is useful. Thank you all for your patience.